one of the most important things about logs is trying to remember all your properties. So here is a little box full of properties of logs. Some of the properties that are not listed are stinky, smelly, swirly, maybe piley, but oh wait, wrong kind of logs, my bad. I was thinking like the logs that my son drops in his car's potty, sorry. Those are natural logs, and we'll get to that later. Anyway, if you have a log base A of 1, remember we talked about this one, if you have a 1 here, it's always equal to 0. It doesn't matter what your base is. If we have a log base A of A, that's equal to 1. So we have a log, pink's a real good color to use here. How about I use purple instead? So if we have a log base 8 of 8, well, we're going to figure out what's the exponent we raise a to get 8. Well, that's just a 1. If you have log base a to some power, so say we get the log base, we'll say square root of 2 to the square root of 2 to the third. Okay, these are the same. These radical 2's are the same. So your answer would just be whatever this value is, which is 3, because these basically just cancel each other out. And then if you have a log that has the same base on each side and you have two different values, then those two values are actually equal to each other. And we'll do an example of this here in a moment. So if we have log base 5 of 1, we know since this is a 1 here, that's just going to be equal to 0. For B, we have a log base radical 11 of radical 11. Well, our exponent that's right here is a 1. What are we going to raise the radical 11 to equal radical 11? That's going to be 1. And then we also have, if you have a base 8 that's raised to the power of log base 8 of 30, well, this 8 and this log of 8 cancel, and you end up getting just 30. And that's your solution for that. Now, on the second part where you have to solve, notice you have simplify and solve. Well, simplify is when you don't have an equal sign. Solve is when you have an equal sign. So in each of these cases here on the right, you're going to find out where x is equal to something. So in this case, this log of 3 and this log of 3 cancels, and you just get x is equal to 7. Down here on the bottom, you have this x. Well, this log base 4 and 4, these are the same base. You have an exponent of 1 up here. So what's going to happen is this log base of 4 and this 4 cancel, just like they did over here, right? And you end up getting x is equal to 1. So there are some basic examples of how to use your properties of logarithms.